in building games. I am Priya Jathar, Solution Architect from AWS India. And today's session, I'll be talking about how we are working with customers, helping them innovate in the generative AI space, specifically when they are building their games. Today, I will also be joined by our customer, Winzo Games, where we'll have Manik Bajaj coming and talking about how their experience has been when they're building and using generative AI in their application. First, we will cover what we are understanding from a games perspective in the game industry, how generative AI can be used. Then we'll go ahead and see a demo and then go ahead and build a demo where we can introduce generative AI in an existing application. Post that, we will understand some of the customer use case and understand from Winzo team how they have actually taken up this generative AI journey. And then finally, we'll learn about how some solutions are available which you can use ready when you're going to be speeding up your generative AI application build. When we see in the game industry, we are classifying it into different classes, right? The first is we are helping game developers actually build games easily and quickly, and how we can actually innovate in that space. The next is actually the in-game features which we are having, where we want to engage the players as they are in the play, and how we can actually improve that experience when they are participating. And the third is, of course, supporting in the publishing operations, where we are helping the marketing team or enabling communities of gamers when they are actually engaging. Now we will see how we are actually using generative AI to really enhance and improve some of these experiences as in each of these classes, right? The first one of in the game development area, what we are seeing is there are a lot of content that's getting generated every day. Different types of content which is getting built in the game. For example, you have animation, you have music, code assistance, and of course, game asset tagging. When we were looking at a game, building artifacts and assets like animation, music is quite difficult, and building and managing this asset is critical because that's the way you're going to be engaging with your players. We are also seeing that whatever assets that you're building, obviously, even if you're using generative AI, you still need to have a human touch to evaluate and see how much of that content can be really passed. From a content moderation perspective, also we are seeing a lot of innovation that's happening, but also things that we need to watch out, which we'll be talking about later. The stack which you're seeing here, the light, is basically the ready-to-build Amazon AWS solutions that we have in place and partner solutions which can help you build these and enable this in your applications quickly. The next layer where we have is there we have got a lot of AWS services which can help you build these services and this implementation along with AWS services and partner services. And the third area which you are seeing, more so where we are seeing there is a lot of experimentation and innovation going on in the industry, and we are still working with customers and within our own internal teams to see how we can innovate and bring solutions out of the box for you all to easily use it. So now we will dive into some of each of these areas. We'll have one use case which we'll see in the game development area, in the in-game experience, and of course in the publishing operations as well. So let's start with first a demo. This is a game which is basically built by our team. Okay. Yeah. And it's just built for fun. So it's totally built using generative AI solutions, wherein it's a simple game where you're given a theme and you're a detective and you're going to be engaging the game to identify who is the criminal, who was committed the murder. And if you see, there are different characters which are given. Within a time-bound area, you can actually interrogate or talk to each of the suspects and then finally identify who is going to be the killer and then bring it up and suggest. And that's how you play the game. The whole game was built using generative AI, and we used serverless services overall for basically able to scale as and when the demand goes high. This is just a sample of how an application can be built, and we have got a reference architecture which I can share that. But having said it, this same example you can actually extrapolate to the real games that you may be building and using generative AI to quickly build this within a few clicks, right? And here you say that actually having a conversation with each of this using a conversational chatbot facility in context. So the application is actually responding depending on the question you're given and the script of what the plot is about. In context to that, you're getting a response, right? And finally, when you finish the game, you get to know if you're a winner or a loser. And in this case, well, I have actually won the game. So you can build such chatbots or applications very quickly and easily with some of the AWS services, which I'll be talking about. Now, whenever we are talking to customers of different scale and sizes, everybody wants to see how they can quickly come about and build this application. But having said that, they have a lot of questions in their mind. First is, what kind of model do I use, right? How can I quickly build this and bring it to production, and then just from the experimental stage? And then, of course, most critical is, like, is the data that I'm going to use to build this app, how secure is it? Is it going to be used by others, or how private can I manage it as well? So now we will look at how this can be done. Some of the other questions that people are having is that one of the challenges with all of these foundation models are there are a large number of these foundation models, right? And it takes a lot of effort to identify which of these models is best suited. And there's no one model that can actually suit all of your use cases. So there's a continuous process in which you'll have to evaluate different models, identify which one is best for your application, and go ahead and implement it. So we are finding how we can actually enable and help customers do this quickly, easily. Second is customizing these models, right? Generative AI models are generally built on open data, right? Now you want to bring it to context to your organization and have responses to that. So how can you customize them quickly and easily? And of course, keeping security and data privacy in mind. Second aspect is generative AI models are generally good at generating content. They're good at doing a conversation with you, but they're not really good at doing some actions, right? Like whenever we are evolving, we are seeing that applications are also requiring a need to create some actions and do some tasks. Like for example, in a travel booking case, you may want to have a travel booking, the steps of travel booking to be put in, or an insurance claim kind of example. So if you want to go there and have generative AI actually help you do these actions and do it quickly and manage the whole life cycle of them as well. And of course, you want to seamlessly connect your data source, making it simple using configurations and not really having to go write a lot of code and keep on changing and managing that. So how do we simplify that? And of course, we want to do all of this at scale. We know that as your game gets popular, obviously there are going to be a lot of concurrent users going to be acting and going to be playing continuously, and all this in-game experience that you want to give have to be scalable and performant at high scale. Now let's see how AWS can help you. Now let's see how AWS can help you. We at Amazon believe that the foundation that's needed for building a generative AI application come into 3 layers. We have the bottom layer, which is going to be talked where we give the industry class infrastructure, which can be used to build and train your models at scale, and also do inferencing at scale. We have got specialized chips called Inferentia and Trainium for inferencing and training available. The second layer, the middle layer that we have, is basically all the tools that you can easily use and quickly build your generative AI applications and using the best-in-class large learning models and foundation models. Using Amazon Bedrock, what we can enable is that you can do all your prompt management aspects. You can have knowledge bases connected to connect your organization's data, and of course, you can have agents and guardrails put in, considering responsible AI in mind when you're building your applications. And the third layer we want is where you want to empower that generative AI is within all your applications you're using. So if you're using your browser, or if you're using, as a developer, if you're using your IDE, we want to bring generative AI to those applications itself. And that's where we have these Amazon Q range of products which will help you do. In today's session, I will be showing you how you can build a generative AI application using Bedrock and, of course, Amazon Q as a developer. So let's get started. First, I want to introduce what Amazon Bedrock is about. Amazon Bedrock is a fully managed AWS service, which is having a choice of foundation models from the world-class third-party and Amazon companies, like for example, from Cohere, Stability AI, AI Labs, etc., which you can use and build your own applications, right? The advantage of having the choice of foundation models is you can quickly pick and choose them, and you can also customize them to suit your use case. So the model customization part is also something that we provide. And of course, whenever you're going to be having your corporate data coming in and going to build the applications, you obviously need to build something like the retrieval augmented generation called as RAG, and having agents perform some of these more complex tasks that you want to do. And of course, keeping security and privacy in context. Now let's go ahead and look at one of the, along with that, what we are also going to show in the demo today is Amazon Q for Developer. This is like a code assistant which you can have in various of your IDEs or wherever you're building your code. And using this quickly, you can understand and help the various SDLC lifecycle as a developer which you have. In each of those layers, we actually have something to help you do that. So at code building time, called understanding of existing code for new developers, and of course aspects of testing, debugging, and even some of the security checks that you would want to do. And every of the places where you're going to have a touch point, you can actually converse with the code that you're having. For example, if you see in all of the places, how many of you, I don't know, have used Amazon Q? It's even available in the console, using which you can understand what's happening. And of course, same way in the IDs and the documentation others. I'll be talking about and showing this in the demo, so let's quickly jump over to that. Let's first understand what my demo use case is about. Sorry about that. So in this case, what I have built is a game which is going to be like an in-game tutorial, right? So a new player has come in, and typically new players who have signed in may not really know all the aspects of the game, and they need to know if they don't win or they don't know how to play and use that, they basically will log off and go. So how can we improve the experience of a player who's coming in and playing the game? For simplicity, what I've used is a simple example of using Rummy as a game, because most of us understand Rummy, and it's simple for me to elaborate, so that's why. But the same thing can be done for any game of your choice, whichever you're building within your organization. Now let's go ahead and look at the demo. So first I've recorded it so that we don't have the network challenges. So if you're interested in really coming and seeing the demo in person, we'll be happy to actually show it to you as well, right? So the first thing that what we're doing is we're going to be logging into Amazon Bedrock. This is the AWS console, and you will be logging to the Amazon Bedrock, and you will understand what are the things there within available here, right? So we basically have the various aspects. We have the foundation models available. You have the playground, wherein you can do the chat and image generation aspects. We have builder tools like prompt management, knowledge base, agents, and others, which we'll be talking about now. And of course, we have other aspects like model evaluation, and of course, a studio wherein you can go ahead and develop. Now let's go in first and see how we can actually use a playground and understand and create a simple thing with text generation with the playground, right? So here first thing what I do is I'm choosing a mode either for chat or for text. Now I'm going to be using for a chat because that's what I want to do. And I'll select the model of choice, right? Like I told you, there are various industry class AI providers, model providers, and we have got a choice of them here. You can go ahead and choose which of the models you want to use. In this case, I'm going to be using Anthropic, and I'm going to use the Claude Sonnet 3.5 model, right? What I want to do is basically from a card, set of card of an image. I've captured an image of a hand of a particular person playing Rummy, and we're going to be identifying the cards and then seeing how the generative AI can do that quickly within a few commands given in the prompt, right? So what I do, I go ahead and I identify the various settings of the temperature and the top P and other parameters that I want to pass for inferencing, and I'm actually creating the system prompt, right? Here I'm just telling that the base of this particular goal is that you are having already knowledge about playing Rummy, right? And always answer the questions in context to this, right? This way what the prompt will do is not giving a generic answer understanding something, but give an answer in specific to the game of Rummy, right? Now I'll go ahead and write the prompt as an end user, and I'm choosing the file, and you see that I've got a set of hand of Rummy with place there. And there it goes, and once I put that, it actually goes and identifies the cards, right? I just want to bring to your attention, though my picture had actually 10 cards, it actually went ahead and identified 11 cards there, right? So what's just happened here is the LLM model has actually hallucinated. It's actually generated one extra prompt, extra card, thinking that. So this is a typical challenge, and this can be very easily done in various ways, and one of the ways you can do is just writing your prompt more effectively. Go ahead and write a clearer prompt saying that you are only looking for the specific 10 cards, right? And also you can ask them to go and recheck it before showing the response, right? So all LLM models with the prompt, it go and recheck the response before showing it to you. And now if I say, okay, it goes ahead and identifies exactly the 10 cards, you can actually check. It's a right sequence in the series that's run, and it also tells you that it's gone ahead and done the recheck as well. So this way what you can do is within your gameplay, wherever instances of game is executing, you can actually capture images of that and pass it in the pipeline and do this analysis. So the end user, later if he wants to go back and see what happened, how was my gameplay, what could have been done differently and ask, you can also enable that kind of feature. We already have an AWS solution which will help you take the images, holding and the whole pipeline for that. So you can use the pipeline for that, and then using that you can quickly use this in your application. Now I'll go ahead and say, okay, we saw what you can do with text. Now let's go and see about an image, right? In all the games, you always want to build new characters. Either you build it in a repository and keep it before, or you could also keep it in real game as well, right? If you want to, you can also call this as an API, and really as when the game is happening, you can introduce new characters and other aspects to it. So in this time, same way, like in the earlier case, I'm just writing a prompt and I'm creating an image. And this image, in this case, I'm just using from text. You can also give a seed image and say that on the similar looking image, you create more variations. And I'm using the out-of-the-box model, which is available from Stable Diffusion for this, for the demo purpose. And you see that I've asked for a model of a person, of a boy, like a prince with some weapons and different poses, right? You can see that with similarity, it's kind of created the same characters, right? So in this way, we can, just like how we can do an image, you can also do other kind of generations and use this to build your app, build your game, right? Now let me just go ahead. Now that we saw, as important as the prompt is when you're going to be building a generative wave applications, we need to know how you're going to be managing the prompt, building the prompt and managing the life cycle of it. Because as you're developing, obviously you'll have various versions and evolution of that, and then you need to have a place for it. So we have got a prompt management facility as a tool wherein you can actually go ahead and build these various prompts and manage its life cycle. In this case, for example, you can also pass parameters. Like for example here, what I'm telling is that I want you to be like a game developer, and I want to specify which type of game I want to have. So you see whatever I put as a card game is actually parametrics which you can pass when you're calling the API for the prompt. And then you test it, and obviously you can associate the prompt either with a model directly, or you can also associate it with an agent. Right? In this case, I'm doing with a model, and again I'm choosing Sonnet 3.5, and of course the necessary inference parameters. You can also specify exactly when you're calling this as an API, the JSON structure from where the parameter value will be coming in. So the configuration tools, you can use that for that, and whatever you're seeing on the screen, all of this can be done through API. So that's why the configuration for that you can specify there. And as I mentioned, right, you can create versions, and you can also do comparison of variants as well, right? Because the responses for each of the prompts, whichever parameters you're giving, it's going to be different. So it's very difficult for us to go ahead and remember and all of that doing offline. So you can actually do the comparison here itself and then decide which is the right prompt for you at the current time. And of course, do the test and see the feedback. So if you see the feedback, it actually has told you, in this case I've asked, how do I build a game, right, like Rummy. You can see that it's actually gone ahead and told what could be the game design like, what would be the development parameters, and all the aspects which you would want to think about when you're looking at a game. So, but what you see till now is basically what already the large learning model has learned, right? It's nothing from your own corporate data or respect to your game. But what you want to go is that you should be able to answer questions which is relevant to your game and context to what the player is doing in the game. So now let's go ahead and see how we can do that with knowledge bases, right? Knowledge bases are managed RAG solution which is already available out of the box for you from Bedrock, wherein you can just integrate and connect all your backend systems. So let's go ahead and see how you can do that. Now I'm going to create a knowledge base which is going to be looking at a website and getting information of how to play Rummy in that site. I'm taking Winzo website as an example for demonstration purpose. And here I can say that, okay, with the right permissions for the users, I'm going to give whatever the backend data source where the knowledge base is going to get powered from, right? It could be static files which you have put in S3, or it could be the web crawler which I'm going to use, and I'm going to crawl the Winzo website, or it could be from SaaS applications as well. So if you have things which is there already in Salesforce or in SharePoint, you can quickly go ahead and connect to them and give the right configurations. Post that, what you will actually do is that we'll give the site, and we'll also have some advanced parameters to say that to what level of depth do you want to do the crawling to be, right? And you can choose and the rate of in which the crawling should happen as well. You can also have some other configurations like what patterns to include, exclude, and things like that. Maybe we don't want to go ahead and crawl a lot of content. You need to be prudent about that. And of course, whatever text data that you're going to be reading, you would want to store it somewhere, right? And that's where you define how you're going to be a chunking strategy. And here I'm using default. Of course, you can have other advanced strategies as well for chunking. Now, what is actually happening behind the scene when you're doing a RAG implementation? All the textual data that's going to be there are converted to vectors, right? As we know, computers and algorithms always are very efficient when they're going to be in the vector format, right? So using any embedding, right? It could be a text embedding or a multi-model embedding, whichever embedding that you're using is actually going to do this job of converting all of this text or voice or whatever into a vector format and storing it somewhere, right? And all the retrieval and the checks and queries that you're going to be doing are actually going to be in the vector format. So you need to identify which embedding model you'll be using here, and here I'm using Titan Embedding 2, and then choose the vector store, you're going to be storing it as well, right? So in the configuration flow, you can actually choose that, and you can also choose the vector dimensions. You have various options, and here I'm choosing 1024 as a dimension, and then you go ahead and store in the vector store, right? Next step, what you do is that you will actually store, you have a choice, right? Do you want to do it in the default, which is going to be Amazon OpenSearch serverless, or do you want to have your own choice of vector store, right? In your organization, if you're already using something like a Postgre, and you want to keep it close to that, you can do that as well. So if you have a choice of various vector stores, and you can build your own and choose whichever configuration you want, and you can go ahead. Now what I'm doing is I'm actually going ahead and creating the knowledge base. Now behind the scene, what's happening? It's actually provisioning an Amazon OpenSearch serverless instance behind the scene, and it is also making the necessary indexes for that and for us to set up the full vector store itself, right? Till now what we did is that we identified that we are going to be scraping content from the Windsor website and converting it to embedding, storing it as vector in the vector store. Now the next aspect, what will happen is that we'll have to go ahead and synchronize it, right? Now only the setup has happened. Now I will go and see the data source is created, okay? Let's go and check that it is from the Windsor site as we configured, and then I will say, okay, now go ahead and synchronize, right? When I'm doing the synchronizing is when actually it's going to scrape and do this activity which I just mentioned a few minutes back, and store it into indexes so that whenever you're querying the OpenSearch, you will be able to get that information quickly, right? You could use semantic search or hybrid search, whatever, to get the information from the vector store. Now let's go ahead and let the synchronization happen. It could take a long while because it's been depending on the amount of data that you're actually going to be doing synchronizing. You can always have batch mode or configure a schedule so that the synchronization happens at a regular period as well. What I showed you now was actually a manual way, but you can always schedule it. Now in the meantime, what can we do? Once that we have the knowledge, the corporate data of what we want to do in the game in the knowledge base, let's go ahead and build an agent, okay? Now what is an agent? Agent is basically lets you do more complex tasks which have a sequence of tasks that want to be executed. So all the action that you want to do as a part of your application is something that you can configure an agent, right? So let's go create the agent which is like in-game tutorial, right? So Rummy tutorial is the agent that I'm building, and it will basically tell you how to play Rummy, right? So all the questions and queries on how to play Rummy on Windsor, we can answer those questions here. Give the necessary permissions, select the model that you want to use, and go ahead and give your prompt, right? So in this case, what I have done, the prompt, oops, sorry about that. I think Murphy hits. So what I'm going to be doing is that I'm going to choose and give the specific prompt saying that I want it to act like a Rummy expert, okay? And it wants to answer all the questions from the knowledge base itself, okay? And each of the players can ask different questions, right? Because you're giving it as a conversational mode, right? And you will only be answering questions which is out of the knowledge base, and if something is not there, then you will politely respond saying that it is not available, right? We will also add some actions to this saying that if a customer, depending on the subscription type of the customer, maybe you want to do some checks, and these checks will be from the backend systems, right? So I'm going to be having a backend system where it's storing information of the customers and subscription and the game wins and things like that in a DynamoDB database, and that will be the one which will be called as action here. Now let's start with giving a prompt first. So in the prompt I'm saying, okay, this is what I want to achieve. Okay, and I can also do some more configuration saying that if the user didn't give all the criteria for the question asked, right, can I go back and ask the user some questions, right? So I'm enabling user input. Also aspects of code interpretation, if I want, I can enable that. We can also see how much idle timeout you want to keep. Now let's go ahead and save it and then go ahead and create a action group, right? So I have two actions which I've thought of in this gameplay, where it will be like one is a player info, which is getting basic information of the player. And I'm going to implement this as a lambda function, and these will be two methods in the lambda function, right? And the first function, it will be get info, and I'm going to pass the player name as a parameter, right? So I can quickly go and define that. And the next method I'm going to have is basically get the player game ID score, okay? And there will be two parameters, it's player ID and game ID, right? And I will configure these two actions. So if a question from a customer comes like about the game or what about the score I did in the last game, then it will answer these questions. Now the interesting thing in a model is that you can also have a memory enabled, so that in the agent that it can remember the past conversations up to 30 days. So you don't need to code and think how will I do all that. So basic session management aspects of it is taken care of. Beyond that, if you want to do historic, also that is taken care of. Now let's go and bring it to the organization's context, right? Like let's include the knowledge base that we had built a few minutes back into this agent, right? So it will answer exactly, you can give another prompt saying from the knowledge base, what are the things it can get information about. So when the agent is actually looking and understanding the question of the customer, it will actually go ahead and look at which is the best source for this data, right? Is it the knowledge base, or is it going to be from a database which I need to invoke an action, right? So give that and go ahead and save it, and you can go and publish. Now what we have done, by creating that agent action, we have actually created one dummy lambda, okay? And you see that the dummy lambda is having just a basic structure of getting invoked from the function, right? Now we need to do is that we are going to put the real business logic and context, right? And I'm a believer that I want to use generative AI even when I'm writing code. So I'm copying it, and I have actually used VS Studio here for the code development, right? I've already configured an extension of VS Code with Amazon Q for developer. So what it will do is that as and when I'm playing, as and when I'm typing here, it will automatically prompt me what are the things I can do. So let me first go and say, okay, I want help in writing the first method, which is basically to get information of the player, right? And what you see now here is automatically it gives me the definition of the player info, and it tells me what could be that, and it's identified that maybe probability could be I want to use DynamoDB, so it's given me the necessary connects for going to DynamoDB. So this is one mode wherein you can look at your existing code, type in, and it will give you intelligence of how to generate the code. The other option is that you have a chat, right? You can chat in the window and tell that I want to create a lambda and I want to do this. So you can also converse with your code, right? Tell that I'm interested in doing this, tell me how should I do it, right? So there are many times when as a developer you may not really know exact syntax, right? Or what are the best practices. By doing this conversational way you can do it. So it understands what you've done because it's already been trained on Amazon data and best practices of various Amazon services implementation. And what you will see is that it has actually told you many things, right? First is it's told the best practices, what to use, you know, if you want to do for a, so it's telling me, it's giving me more prompts than what I asked for, right? So if you observe, it says, do you want to handle multiple player scores or do you want for individual? Though I said that get me a player score. So it's actually used the intelligence beyond what you could build in this capability. Next, it also tells you the best practices from a error handling perspective, right? So when you're writing anything with any code, that how could be the best practice of error handling. What it's also done is it's generated the code for me, right? So if you see here, it's generated the method which is going to be get player score, right? And whatever parameters I wrote in the prompt, it's just taken it up, right? And you can look at the code and see is this suiting to your requirement, and if it is, then just go ahead and say insert the cursor, insert. So automatically wherever the cursor is in the main page, it will go ahead and insert the code, and voila, you have the code which you want to do. So like this, iteratively you can use Amazon Q for developer and quickly build your code. And once you're done writing all of that, just copy it and put it into the Lambda function. Do all the necessary configurations of Lambda, the security configuration role and other permissions, and then you can go and deploy. Now that I've done that part of the cycle, I'll go ahead and prepare my agent and test it, right? Same way, like in the earlier cases, I'll go ahead and say I'm testing, but what I'm doing this time is instead of giving an image, I've just put it as text, right? Whatever is my hand, the cards that I have in my hand, and I'm asking what are my options? Which card should I pick, and what card should I discard? So what it does is that large learning model actually understands, Sonnet 3.5 understands what I've asked, and it actually gives me, helps me in with a response, right? So it tells me, it gives me suggestions. So if you see here, it actually understands what are the cards that I'm having. It has understood the relationship between the cards from basis of rummy rules, right? And it is also told that what would be the strategies for you to play the next. So it's like a tutorial telling you what are the options, what could you do, and how can you improve, right? And if you go ahead and see, the information that you're getting here is actually, oh God, sorry about that. It's a little too sensitive, it's time, okay. Okay, and what you see actually is basically it's coming from the knowledge base that we have taken, right? So this way we want to say that we can actually use Amazon Bedrock to build generative AI applications. We also have guardrails, model evaluation, and various other aspects which are there, which you can use when you're building a game. You don't need to necessarily come to the console. We also have a studio, so you can, end users can just log in with their permissions to the studio and do all of this application game development as well. Now that we have learned how to build, let's see in concept what are the things that is there which have helped us build it. So you have a choice, you can customization, you can do integration, and you can do security and governance with this. And we saw some of these models which you've already talked about in the demo. I will just skip through in paucity of time. We can always catch up in the booth and I can explain and elaborate all of these to you in detail. Excuse me for that. Now I would like to invite Manik Bajaj from Winzo, where they have actually experienced and they have built this application and run it on production on scale. So I would want him to come and explain how their journey was on when building this app.
Thank you, Priya. And can we have a round of applause for Priya for the great presentation?
Thank you.
So now I'm going to be talking about how Winzo has been using generative AI for supercharging our customer support. So basically, I'll not be as technical as Priya. I'm going to talk in layman terms. So what generative AI helps us do is basically use large databases to generate responses in the form of text or media. Like Priya already demonstrated that we can create text responses as well as images. And given what the technology offers, customer support becomes a very natural use case to be addressed through generative AI, given the large variety of queries which are coming in and which need to be addressed accurately and quickly. So that's where we started using AWS Bedrock, and we created a LLM-based model to supercharge our customer support. So I'll quickly talk about the journey why we moved to generative AI. So initially, once we started off, the customer support was majorly done by agents, and it was more like a manual process, and definitely it was not a scalable solution. If you know about Winzo, we've currently been venturing into global markets, and if you rely on the agents, what you're going to end up doing is hire in every geography, and that's not a scalable solution. And you also want to be customer centric in terms of solving customer queries as quickly as possible and as accurately as possible. Also, the traditional support agents is prone to error, prone to mistakes. Then we came up with an interim solution that we built in-house, which was basically a decision tree-based solution, wherein for every feature you have certain trees. Let's say if X happens, Y should be the response, and if, let's say, Z happens, A should be the response, and in certain cases you let the customer reach the agent. So that's what we were trying to do. But again, it was slowing us down. And that's when we started exploring large language models, and we built a robust solution using generative AI with collaboration with AWS. And this partnership with AWS has been instrumental in terms of powering our customer support related generative AI model. So some of the key insights through thorough investigation of our user queries was that 95% of the queries are very simple in nature and can be addressed through automated responses. And that's where we thought that we should include an automated generative AI model to address these queries. However, I mean, it's fine for simple queries, but as far as complex queries are concerned, we still have some manual intervention as we're still trying to improve this model. As far as the AWS technologies are concerned, we use AWS Bedrock to host our LLM models. We use AWS SageMaker to inference what the user is trying to talk. And we use OpenSearch in order to answer queries which are not related to Winzo. A user might just type in anything and want a response. Can you move to the previous slide? Yeah. So that's how the architecture of this model works. A user basically inputs either in the form of text or voice. We obviously use voice to text, and that's where we get what the user is trying to say. as far as the large databases are concerned, we have a lot of documents in-house, be it the PRDs, our websites, and a lot more documents that we use as the base to answer these queries. So most of the queries that the user asks, we classify these into 3 categories. These categories include transactional queries, there are non-transactional FAQ type of queries that we have, and then there are non-domain specific queries that a user might ask, for which we use open search by AWS. So like Priya mentioned that this technology heavily relies on vectors for it to be more accurate and more faster. Sorry about that, we just moved. Yeah. So essentially there are 2 modules which are feeding into our LLM. One is the inferencing module, for which we use AWS SageMaker to understand what the user is trying to say. Then we have our training modules wherein we have our own databases, and we pick fragments from these databases which are further converted into vectors to be able to answer these queries. And these are fed to AWS Bedrock, and we have a multi-agent framework that is able to generate the response to these queries. And after the response has been generated, it converts it to the user's regional language, and the user is able to get a response which he understands. So this helped us build a globally scalable solution using generative AI. And finally, we take a feedback from the user in terms of whether he liked the response, whether the response was partially correct, fully correct, and we feed that information into our model to make it more accurate, to make it more reliable for the consecutive users. And now I'm going to show you a quick demo of the 3 transaction categories that I just mentioned. So the first category is basically transactional queries, and if you look at the query, basically the query says that the user was not able to add cash. Let's say he added some cash to the wallet and the transaction was still pending. And this is what the agent does.
Sorry about that. No, it's okay. It's too sensitive. Yeah.
Right. So an agent might ask the user for some time to be able to resolve that query, and on the average time to resolve a query was around 9 minutes. Then we started using generative AI, and we call this solution as Vinzica.ai, which is inspired from Vinzo. And this is where a user said that he was not able to add cash. The bot replies that these are the potential issues, and these are some of the transactions that you have done recently. And the user can select one of the transactions in which he faced that issue. And the bot basically replies that the transaction is still pending at the bank's end. So the total time taken was reduced significantly, and it essentially helps us provide a quick resolution to the queries. The time like you can see, the time reduced was to 30 seconds. Now we'll come on to the other 2 categories of transactions that we just talked about. So a user may end up asking a FAQ type of query, and these type of queries cannot really be addressed through the decision tree model that I talked about. So a user is asking, what is Vinzo Wallet? Explain me the different components of it. And through our databases, we're able to answer these queries fairly quickly. And the third type of query that a user may ask could be non-domain specific. It just could be anything. Who won India versus New Zealand match? Right. So basically, the open search here helps us answer accurately, and at the same time, we also use hallucination evaluators to assess whether the created response was factually correct or incorrect. And these are some of the outcomes that have come out of this solution. It has helped us build a scalable solution and a more globally scalable solution where you need to respond to the users in different languages. It has definitely enhanced user experience in terms of the wait times. The efficiency has improved and the overall satisfaction of the user has also improved. So I think this is what we're trying to do. We're still trying to improve this model, and it's great partnering with AWS for this generative AI infrastructure that they have in place.
Yep. Thank you, Manik. And it was quite interesting that we heard how actually the idea of how to build, and it's been really used in reality with them, and you have seen their application which is actually doing it. Thank you once again. I just want to conclude with summarizing with the last use case. This is basically from a publishing use case per se, where we are talking about user-generated content, right? To make games more interesting, what have we done? We have gathering various user content, for example, reviews, conversation, and aspects like that, brought into the game. One of the problem with this is that content could be very varied, and you may want to actually control and moderate this content, right? You want to remove all these. You want to keep it safe, remove all the toxic and abusive language. And what we have actually as a solution which is augmented along with generative AI is to identify all this content of different types, right? Image, audio, video, text, all of these, using multimodal capabilities to do the moderation, right? I can just show you, with paucity of time, just going to show about what it is about at a high level. We can augment it along with AWS services like which helps like transcribe, which does voice to text, and augment that along with the large learning model, and then get your right moderation in place. We got a solution available for this. You can actually scan the QR and use. And just to summarize, what we saw today in this session was about how we can use generative AI when you're actually building a game, right? Using Amazon Q for Developer to write the code. How you can improve Amazon game experience using or building something like a tutorial which we saw in this demo. And of course other artifacts, right? It could be artifacts like images or characters and other artifacts of voice, music and things like that generated. And of course moderation, and also you could do something like live post for your call center agents, how their performance, analyzing the call discussion along with the customer and see how you can improve. So with this, I would like to conclude this talk and encourage all of you to go ahead and start moving and adopting generative AI. Identify the right use case, empower, learn, build your skills on what, it's an evolving area. So we've got a lot of assets from AWS using which you can actually learn, and then happy building. Would like to thank you, and would like to thank Manik as well.
This? Guys, we'll like to have a group photograph. Can I invite everyone to the stage, please? We'd like to have a group photograph.
This one?
Yeah. Can you all come on the stage, please? Thank you.